All right, good morning. Thank you for coming. Thank you for coming. Let me get my little flipper over here. Thank you. Who knows Walter White? Yeah, thank you. Let's see. I actually did a session in Germany last week on Breaking Bad SharePoint. And I took each of the characters from Breaking Bad and aligned them with how a bad project happens. It lines up pretty well with Breaking Bad. If you'd like to see that, I'll see you in the speaker room afterwards. I am Mark Miller. There's Jeff Williams, Ryan Berg. And we're gonna do something different here, because what we want to do here is have an open discussion about a new piece of the top 10, which is the A9, about good components and good component practice. So what we want to do is talk with Jeff and Ryan about their experiences with components. We want to talk to you too. I've got an extra microphone. If anything comes up, just raise your hand. I'll run out and give you the microphone so that we can talk directly with them. Jeff, if you would, give a little background. Just say hi, your little bio. What you got?
Yeah, sure. Hi, I'm Jeff Williams. Some of you may recognize me from my work on OWASP Top 10 or WebGoat or the Enterprise Security API and a bunch of other projects here. I was the chair of OWASP for 8 years. I'm currently the CEO of AppSecUSA, and if you're smart and humble and really passionate about AppSec, we've got some awesome jobs available. And if you're tired of hassling with static analysis tools, you might stop by our booth. We're showing a tool called Contrast.
Thank you, Jay.
And I'm Ryan Berg. You may know of me or not. I started a company, 10 years ago called Ounce Labs, which did static source code analysis. For those of you that have had the pleasure of using static source code analysis, I'm sorry. I apologize for that. But I am now the CSO of a company called Sototype. We look at the open source community, a lot of community projects, and understanding how the use of open source has become so prevalent. And it really is opening up a sort of new area from my perspective of how we look at software security, because the way in which we are assembling our applications is really fundamentally changed. And it was a watershed moment for me when I realized that, I built a technology, I spent, N number of years looking at security vulnerabilities, and I missed this whole space completely. I didn't even recognize it, even though it was right in front of my eyes.
Good, thank you. I am Mark Miller, and I run the Trusted Software Alliance. And I also, as of this month, I am the podcaster for OWASP, which we've got 43,000 members and about 13,000 to 15,000 listeners. So if you go to OWASP and just check for podcast, I've actually done 15 interviews in the last 2 days here, and I'm just going to be pounding them up as fast as I can get them. So what I'd like to do with that series is to introduce you to the project leads of each of the projects. There's 190 of them in OWASP. I'm getting each project lead to talk about what they're doing so that they can get exposure for the projects they're on. So would appreciate your support on that. How many people are on Twitter right now? Good. You know the hashtag? AppSecUSA, because Jeff's going to be very controversial today. Just today. We'll see what we can do. I want to throw a slide up here. Have you seen this before? This is new to a lot of people. The idea that components are a major piece of major applications here. Jeff, why don't you take a shot at this one just to start? When you first saw this, did this surprise you?
Well, so I started noticing this trend 3 or 4 years ago, that in our security practice, we were noticing that applications were becoming more and more composed of libraries. Like we saw libraries start to grow from 10 libraries in an app to 20 to 50 to 200. And when you look at the proportion of the code, you still have 500,000 lines of custom code, but then now you've got potentially, 10 million, 20 million lines of library code in your application. And it just started exploding, and so that's one of the reasons I started really looking into that area and what kinds of risks that was exposing us to.
Yeah. Ryan, part of this too is, even around the conference here as we're walking around, 90% of the vendors are talking about source code. Hardly anybody's talking about components.
Because I think it's one of those things where we kind of taken it for granted. I took it for granted. I remember when I was doing Outs Labs and I was working on a static source code analysis engine, one of the challenges or problems we ran on early on was these class paths were too big. Right? We try and analyze an application, and you try and load up the class path because you need all the classes to get all the references, to do data flow analysis, and all that goes along with that. But we had like a 1K buffer, and all of a sudden we're not able to load all the classes. And even now, it's like I look back, like that was not a watershed moment for me. I wasn't thinking, in fact, oh, well, here's all this other stuff, because I was purely saying, I just want this so that I can compile the code, so that I can actually analyze what I think the code actually is, not realizing that, oh my God, I'm bringing in the entire universe and really not paying attention to it, at all. So I often argue that, it's even greater than, in many cases, it's even greater than 80%. I like to say it's 90. I've done examples where it's up 99. I wrote an app the other day where I was doing a basic web service, so I used Drop Wizard, and of course I want to publish my REST endpoint, so I use Swagger, and of course I have logging, so I have how many different versions of Log4j. Oh, wait a minute, I don't use it anymore. I use SLF4j. Oh, wait a minute, I have to use Logback. And oh, wait a minute, I'm going to run that on a Jetty server, and I'm going to do that. Oh, but I want to actually publish JSON, so I need Jersey and I need Jackson. And next thing you know, I look at my dependency tree of what I've actually brought into my application. I write 1,000 lines of code, and I've got over 100 different libraries that are hundreds of thousands of lines of code. And so, to me, that number is grossly underestimated from most enterprises. Even if you look at the average banking application, which could be millions of lines of code, all I'm saying is that, look at the class path.
But it is a misleading number. Okay, so, that is true. The gross composition of your application looks like that, but it doesn't mean that you're using every single line of code of those libraries, right? So in the example you just gave, you've probably got a few paths down through a few of those libraries. I'd be willing to bet half those libraries are never invoked, none of the classes. They're only there because they're a dependency required to compile one of the other dependencies of your application. And so we need to be careful when we talk about this. It's not that 80% of the risks are going to be in those libraries, right? I think you have to, it's a little deeper appreciation. I sort of think about a tree at the top is your custom code, and then the roots extend down into those custom libraries across some path, and you need to think about what paths of those libraries you're actually invoking.
I mean, yes and no. I mean, in the purest sense, yes. I actually like to say that it's a reflective language, right? So it's on the class path, therefore it's callable. So you're always sort of 1 degree, from, okay, if it's on the class path and you can actually call it. Look at OGNL, right? Well, OGNL in structs is an example of here's an expression language which allows me to call anything. Well, if anything's on the class path and I can call anything that's on the class path, then it is.
Oh, now wait a second. Just because it's on the class path doesn't mean an attacker can invoke it, right? It's only if you as the developer cause that to be invoked in some way.
We can
right?
assume that. It's
Okay.
it's always safe to assume.
So sure, but that's not a library problem, right? Like now we're getting out of bounds. That's another vulnerability, and I just want to be clear, I love developers.
How are you, Steve Ballmer?
We don't. I'm not going to jump around the stage, but yeah, basically. We're not insulting developers here. We love developers at OWASP.
One of the things that is remarkable to me in this whole discussion is the ubiquity of components, to the point, I mean, we can watch the downloads from the repository and see that we're getting 20 million downloads a week as far as components are concerned. That's a hefty number, right?
Well, so it's literally exponential. And this is, if we just look at it purely even on the Java side, right? And there's multiple ecosystems, right? There's JavaScript, there's Scala, there's Python. They all are seeing the same level of explosion. But if we look at the exponential growth of things coming in the Java ecosystem, we see just the same amount of downloads happening as new projects showing up in the first place. And the interesting thing when you look at some of the stats is that people just, there's a couple different waves of organizations. There's people that always like to stay on the latest release. But that's really only like 5%. If I look at just struts, what do you think the most popular version of struts is? It's actually 1.3.8. It's not even struts 2. So globally, struts 1 happens to be the most popular version of struts. And we were actually talking to a jug recently, and there was a guy who came up, and we were talking about struts because everyone's like bashing struts lately. But there was a guy in there, we were talking about struts, and there was questions like, well, what struts version are you on? And he said, I'm on like 1.2. And there's like a collective gasp in the audience, like, oh, you're only on 1.2? And he's like, what? Did I miss something? It was just a realization that these things get into our systems, and then we lose sight of the fact. We're always fast forward what's the latest attack, and we lose sight that it really is growing at such an exponential rate. The train has already left the station. We just have to realize how do we actually deal with it at this point.
So that's actually, that kind of developer reaction is exactly why we thought it was so important to add this to the OWASP Top 10.
Right.
And I did a study at Aspect. We got data from Sonatype to look at downloads and look at how out of date typical libraries are. And specifically, we looked at whether people were still downloading vulnerable versions, and the results were overwhelming. 26% of the downloads from Central were of libraries with known vulnerabilities in them. So that means there's millions of developers. This is 29 million downloads. That's the 26%. So we looked at 113 million total. And that means there's 26 million projects out there that are downloading libraries with known vulnerabilities in them and making it part of their application. And we thought that's a serious risk. Now, if you take a vulnerability like the one that came out last week in in Struts 2, that's something that affects every user of that library and makes their site instantly vulnerable. Well, I don't have data on exactly what percentage of folks are still downloading that library. Ryan, you might. But it's going to be a terrifyingly big number of folks that are just absolutely exposed because they're using the wrong version of a library.
Yeah, I mean, I'm actually in the midst of doing a study where there's really no cause and effect, right? Somehow we're not reaching the broader ecosystem. How many developers are here? Right? And I say developer meaning that you write code and you've written code this week. All right. And how many of you actually pay attention to what happens on NVD? It's actually a little bit higher, which is surprising, but it's not too surprising because we're at OWASP. But if I go and talk to a development organization and say, okay, how many developers know what NVD? They're like, NV who? Is that something I can catch? And they don't really have this cause and effect where what's happening from a security standpoint, these issues are not new. One of the things that you see in NVD is typically when something gets published there, it gets published when there's a known fix. So there's an issue, the vendors take time to actually fix it, and there's a known fix applied, but nobody cares. Nobody pays, so once it's in the build, it's sort of in the build. We see lots of interesting things where people request things that they're not even sure where it's coming from. It's in the build, so like, oh, I'm looking for this thing, and it goes out to the internet saying, do you have this thing? Well, what happens if someone says, yes, I do? are you getting the thing that you expect that you're getting? I mean, it's in the build, and it's completely transparent to a developer because it's outside of what they're thinking of doing, which is, I just want to build this app which has this functionality, and this component thing is going to make my job easier, and I don't really care where it comes from and how many, what I call a roach motel, how many friends it brings with it.
Well, a large percentage of those libraries, the developers never see. They specify a top-level dependency in their POM, and then the tools, modern software tools have automated dependency resolution, which means I bring in a top-level library like Spring or something, and it brings in a whole bunch of second-level dependencies. And some of them have third-level and fourth-level dependencies that they bring in. So when you make a one-line change in your POM to say, I want SLF for J or something, it's going to bring in a whole bunch of libraries to back it up. And so really developers have no way of understanding, no great way of understanding all the stuff that's going to get brought in when they add a little library to do one little thing in their application.
I've got a question out here.
Hi, Zandy Chow from Coverity. Quick question about the figure, the millions of downloads figure.
Yeah.
Is that really about how many builds are occurring, not necessarily how many projects are being used? Because it seems like that would be, essentially recounting every time a project gets rebuilt on a different machine that's not cached every single time. That's another tick on that million.
Yeah, that's right. It's probably not 26 million separate projects or 29 million separate projects. It's
Right.
probably quite a lot of repeat data, but it's also undercounted in a number of serious ways. So many enterprises have their own repository that will only ever get one download, and then all the individual team builds will get masked. So we think that the number is considerably low if you're looking at the overall number of uses of that library. There's really not a great way of getting a perfect measure of how many projects are using a library. There's just not. We can look at the number of organizations that are using a library, and for the study we did, that was 56,000 or 60,000, somewhere right around that number. 60,000 different organizations that were downloading vulnerable libraries. I think there's good evidence that it's pretty widespread. By the way, there's 60,000. A good percentage of those were Fortune 500, Global 500 companies.
Great. We've got another slide here too, if you'll take a look at that. This is stunning for me, but then when I first started working with this, I didn't realize how big the problem was. When you go to some of these larger companies, they could have 20,000 developers in one company, and all of them are consuming components, and it gets to be unmanageable. So when we're looking at this number, do you agree with this number? Some people are going, yeah, nah. All right, good. So Ryan, I'll go with you first. When you're looking at this, and you walk into a company and they don't know what they've got, where do they start?
Well, I mean, part of the challenge of just knowing what your components assumes that you actually know which apps you have in the first place.
Yeah,
right.
yeah.
And typically that's job number one, right? What apps do you actually have? Most organizations don't even know what apps they have. There's a certain list. I mean, there's a certain list, right? Well, we know the critical ones, or at least what we think are the critical ones, but then it's not mapped to which ones are actually in the most use. They apply typically a business risk metric associated with it. Well, if it's web-facing, well, I mean, I've done arguments in the past which says, well, if now in today's world, there's no such thing between an intranet and an internet anymore. Your internet is on the internet. It's a safer assumption to place. So when people say, well, this is my web-facing and this is my internal app, well, your internal is external. I mean, if you've got 20,000 employees, 10,000 employees, even 500 employees, your internal network is better to assume that it's on the internet. So first is, do I actually have a way of doing an inventory of what my apps are? Because you can't even get to the point of knowing what your components are if you don't even know what your apps. So when I think of 2/3 of organizations, first thing is that, well, 2/3, most organizations don't even know what apps they have, let alone think about the components that are in there.
Good. I think as you start to keep your notes here, that's the first checklist, is like, do you know what applications you have, what applications you're running? And most of the time it's going to be no. Jeff, you got something?
Yeah, so, well, the first thing is you should figure out what apps you have and what libraries you have. You need probably some way of instrumenting your organization to figure out what those things are. So, there are tools like Sonotypes that allow you to do that during the build process, and you can instrument your code creation process. There's tools that my company does it at, we instrument the app server, and so we measure directly from the servers what libraries you're using. So there's a lot of ways to get that data pretty easily. Like, that shouldn't be a big problem. But I'm going to challenge this assumption that what you want is a bill of materials. Because really, a bill of materials of libraries, if you have a list of all the jars that you're using to build a particular application, well, you still don't know what you have. It's just a list of, like, foobar.jar and xyz.jar, and you don't know what those things really have in them. And that's really what's most important, is what are you building your application out of? Are those components trustworthy, or are they just crap? And to understand that, it's not a bill of materials. What you want is a product safety data sheet. And that's another kind of document that's used in the manufacturing industry that says, like, hey, I'm going to use these screws to bolt together my rocket or whatever it is. And you get a sheet that says, here's all the attributes of that screw. Its tensile strength and its strength to weight ratio and like a whole bunch of other factors. That's what we really need. Just having a list of parts that don't tell me anything about the parts is, well, it's not really that helpful. What we need is something better, so that we can choose the libraries that we use smartly, intelligently. I don't want to use a library that was written by some guy in a garage in Estonia, right? I want a library that's built and supported by a professional development team that's gone through tests, and that the developers know something about AppSec. There's a bunch of different questions that I would ask. And, if you want to find out more about that, I think, Bob Martin over here is your guy. He's working on a project at NIST to try and figure out a way to capture some of that information that you'd put in a product safety data sheet.
Yeah, I mean, there's a whole set of metadata that you want to have associated with what's in your application, so you can make more refined decisions. As an example, has this project seen an update in the last 6 years? Right, because there are examples of I look at some of the when we look at an application and what its composition is. In some cases, I'm using a component that's had one release, and that release was 10 years ago. So the question becomes, well, what happens if there is a problem? It's likely that there's nobody left around who cares. Right? So that should inform you of making a better decision. Just because Stack Overflow said that, hey, try this, does not necessarily mean that that's a good decision. I mean, I did it. When I first
that's a tweetable moment, by the way.
So I was looking at, I equate, and I'm a developer, so I could pick on them, but I equate a lot of development to, like my kids and their like in music, because I'll get to the reason why, because part of the challenge is if I listen to something like I don't know, Porcupine Tree, they're a little bit too old. My kids probably wouldn't know them, but some band, I listen to it. All of a sudden, my kids are like, that's no longer cool, right? They're sold out. I need to move to the other thing, the cool band that my parents aren't listening to. Well, developers are the same way. I did a query the other day of Web 2.0 frameworks about a month or so ago, and I gave the Stack Overflow. It was like, hey, I'm starting a new Web 2.0 project. Which framework should I use? And it's almost like everyone comes out, well, you could use Struts, a bit like Spring. Spring, they sold out. They went to VMware, they sold out. Everyone's like using Stripes now. I'm like, really? I'd never heard of Stripes. So I Googled Stripes, and lo and behold, there's a new web framework, and of course it has similar issues to all the other web frameworks, but it's the cool thing to go to. I mean, I joked about Log4j. Well, everybody's Logback. It's almost like, oh, well, Log4j, they sold out. Logback's the new way of doing things. And the developer mentality is always, well, I want to use the coolest thing, and I want to be the first person to discover this new library that does this great thing, and then I'll be an expert in it, and then I'll get all my friends, and everyone will say this is the greatest thing. Well, from a business standpoint, those are often very dangerous decisions if that's the way that developers are going to be allowed to choose what's the right thing. So you have to know what you have, and then you have to be able to make more informed decisions about that.
So I think that's exactly right. It's about informed decisions. And actually, in the very early days of OWASP, we were trying to figure out, how do we make a mission statement for OWASP? Like, what are we going to do? And we started talking about visibility and making informed decisions. And we said, the mission for us really should be to make application security visible so that people can make informed decisions about risk. And if you go to the front page of OWASP, that's probably still what it says. I haven't been there in a while. But the reason that we focused on visibility is because if we believe that if it's visible, if everyone can see the same information, then market forces will help people make smart decisions, right? It's out there, people will choose the right thing. But right now, all the metadata is locked up in your head and various tools, and it's not anywhere where it's really visible. So really what A9 is about making one tiny piece of metadata visible to everybody so we can at least not make ridiculously terrible decisions, right? The decision not to use a library with a known vulnerability in it, it's the tiniest step forward. Where Ryan and I were going in the conversation here is like down the road where we actually have, material data safety sheets and all sorts of, advanced metadata. Really, we're just trying to push that line forward a little bit in the top 10. But really, when you're choosing libraries, you should be making decisions. If you've got critical apps, you are literally trusting your entire application to the code that's in that app and whoever wrote that code. And I don't know, how many of you have done code reviews on a library that you download off the internet? So I was expecting a few. There's really not very many people are doing this, right? I've looked at a lot of libraries. And, the code in there varies a lot. Some is terrible, some is good, some is great. It's a broad range. But none of that is visible to the folks on Stack Overflow when they're saying, like, oh, you should do the new crazy thing. That's just not there. So really what I'm about is making this visible so people can make smart choices.
Well, I remember, I started, doing C and C++ where you actually had to, like, use, know the difference between a short and a long. And you had to really pay attention to memory and pointers. And nowadays, developers don't even know what a web request actually looks like. I wrote a paper with the help of Dennis Cruz, or Dennis Cruz did most of the work, and I put my name on it, and about an issue in Spring several years ago. And one of the things, when I went out and talked about it, we said, here's what happens when you get a request in Spring. And I went to the development organization, how many people actually understand what Spring does? It's like magic. Dependency injection is magic. It's like, oh, I annotate my code, and all of a sudden magic happens. Things get populated with values, and they don't understand what's really happening. These things have gotten so complex. The Google engineers write juice. I use juice all the time. I'm like, this is just magic. I write inject, and it magically fills my data structures for me, and all this stuff happens. But if you actually look in and look at, put a debugger in there, and actually hit it like break now, and you look at what's happening, it's like, holy cow. And we just don't understand what's happening in our libraries anymore. We're sort of trusting that, hey, someone must know. The right thing must be happening because nobody, or otherwise people wouldn't be using it, but that's simply not the case.
I've got somebody here, and I'll be back. Okay. But as I'm going to him, one of the things, Ryan, that I think people would be interested in is with the central repository, when people are downloading, what kind of metadata comes with something that comes out of central?
Well,
SHA hash.
Yeah. Well, and I joke about that too, right? I joke about the SHA hash, right? Because it's sort of like, well, how many people actually check the hash, right? A few people, right? And so then what do? You say, okay, well, the hash matches. Okay, most people what they do is they look at the website and they're like, does a hash exist? Yes, download. Right, and there's really no real verification of what you're actually downloading. So I mean, I'm glad you can get sort of hashes, but the kind of metadata that you want. Like, you could build things using Maven toolset. You can get dependency trees, but most people just they.
So
don't really
I wanted to
care.
try to move the conversation a little bit from the problem space to the solution space.
Yep, that's where we're going. Good.
There's two main things it seems like have been highlighted as problems. One is what libraries are you using, and the second one is are those libraries vulnerable? And I think you could probably address those independently, but I'd like to hear any good tools or suggestions for how to do that from a practical point of view.
Thank you.
Sure. So on the first count, what applications do you actually have deployed? There's a number of solutions out there. So you can scan your network for port 80, 4443, and find applications that way. That's not an ideal solution, but it's certainly one. There's passive tools to detect web applications on your network. They watch for traffic on those ports. There are also inventorying tools that you can use. So maybe you do it during CI, and you say, you integrate your build chain and say, here's all the applications we're building. Or you can do it on your app servers. And so I'm partial to the app server approach because to me it represents reality. If you instrument your app servers with a sensor that reports back what apps you're actually running on those app servers, then you can find them all with a lot of details. But that's me. There's a lot of different ways to skin that horse. Cat? So, yeah.
It's as big as a horse, yeah.
On the whatever. So on the second count, are you using vulnerable libraries? Then you've got an exercise, right? So once you know where the apps are, then you need to figure out a way to catalog the libraries that you're using. And that means there's not a difficult problem, right? You're looking for jar files, essentially. There's an open source tool from OWASP called Dependency Check, which does a nice job of this. It scans a file directory and says what jars are in there, and then it looks them all up and checks to see whether any of them have known vulnerabilities. There's also ways of doing it in the build chain. There's also ways of doing that on the app server at runtime as well. So that there's a number of different ways that you can find the libraries that you're using, but there's a problem. So you're going to get a bunch of jar files, and some of them are going to match what you've got in the repository exactly. So you're going to do a SHA-1 hash, and you're going to compare the hashes. Oh yeah, that's log4j, even though you renamed it to that crazy logging thing .jar. It'll match exactly in the bytes. But a lot of people repackage their jars. They'll use shade and move the namespace. They'll repackage the jar into one big jar because they didn't want to deal with a whole bunch of little jars, which is probably a terrible idea, but a lot of people do it. Maybe they even recompiled it from source and they used a different compiler than the person who pushed the thing into the central repository. So then you've got a mismatch. And then what do you do? So there are some technologies for doing a fuzzy match of the jar to the library to try to get a rough identification of it. But that technology is, I don't know of an open source tool that does that. So, there's going to be some unknown libraries in your list, and then you're kind of stuck. You've got to figure out, why are we using an unknown library? Maybe you should use the one where the SHA-1 hash matches.
Yeah, I mean, it goes, that we see that a lot, where organizations, first off is that the first time they actually do an analysis and they scan and say, what do we actually have? And then oftentimes the first time they see anything, what is this unknown stuff? Why is this not known? And we're like, well, because we don't know what it is. And like, well, shouldn't you know? You should know. You should definitely know. Or we see similar matches. And it doesn't even have to be open source components. It's if you're developing your own software and you look at something, you want to be able to say, well, I think it's supposed to be this. But when I look at it over here, whether it's in runtime in a deployment environment, why is it different than what I think it's supposed to be? Chances are it's different for, someone maybe wanted to roll out a patch and didn't go through the regular checking procedures, or it was recompiled on someone's machine that they didn't think, hey, no one will notice. We see this all the time, even like you mentioned, just renaming the jar. Yeah. Because we see people have policies say, you can only use this version of Log4j is the only one that's been approved. And some developers like, yeah, but this is just a point release. Nothing could go wrong in a point release. So I'll just say that it's the same thing. And we see that all the time, where people are renaming things, they repackage things, they move into different namespaces. So part of it is being able to unpack it and do this kind of sort of fuzzing.
I've got some questions going around.
Yeah, sure. Just real quick,
Yeah.
we see about 25% of the jars that we see across, several thousand applications, about 25% are unknown. They might be unknown because the SHA-1 hash doesn't match. They might also be unknown because they're internally developed applications, although that number doesn't include like the basic namespace. So it'll be like some other namespace. If you're, Best Buy, it wouldn't be in the com.bestbuy package. It would be in some other namespace other than that. And we just see weird stuff in jar files that are packaged up for God knows what reason.
Okay, thanks. Go ahead.
So say you do go through all the motions, you know exactly what you're using, you know what versions you're using, but for whatever reason, well, you're stuck on an old, known vulnerable, or an unsupported package or software. What then? I mean, your development system is, well, in some of the cases I've seen, especially with some open source programs, and I'm not a Java guy, so I don't know the difference between struts 1 and 2, but features changed or removed that the older version of the library still maintained. I mean, are there techniques or tools to still move forward with the older version to buy you some time so you can ultimately rebase your app on the new versions?
I think it's really interesting the way the open source community works. You don't take struts 129 and then have, like 1291, 1292 and patch it forward. Like you don't have, like that's not a branch that then has security patches forever. They just put the security patches in the next version of the library that comes out. Right? So if you want to get the security fixes, you also have to take the new features and the new APIs and whatever, you got to port your application to that. So you can get stuck. And to me, there's a trade-off. When you decide to use open source, you're trading off the work that's required to stay up to date with the benefit that you get from using open source. And I'm a huge advocate of using open source. I love open source software, but there's a cost to using it. You're agreeing to take on that burden to keep that software up to date and port your code forward to it.
I mean, we talk about this all the time in software development, where we've got tech debt, right? And it builds up. The challenge is that if you're not paying attention to an open source, right, it gets harder. The further you drift away from mainline development when you choose a project, the greater burden that you have to pay that price forward at some point. So if you don't pay attention and you're kind of like, oh, okay, well I just like use this library that works. I'm only using this one method, and then all of a sudden a vulnerability comes out and you haven't been paying attention and you're on like version 1 and now it's version 3. You're gonna have to pay that cost to move, or you're gonna have to take the burden and say, well, I need to go patch 1 myself. So a lot of organizations aren't really there yet where they're realizing that this burden, I shouldn't say burden, this exposure is happening because of the proliferation of open source and the fact that the longer and farther you drift, the more price you have to pay when an issue, if an issue actually arises.
Great, thanks. Another question here?
First, I appreciate the fact that we are adding open source as a new risk in the OWASP top 10. I think, personally, I think it's really not one of the biggest risks in the software security. So my question is related to the last question. It's about the security advisory from open source library. One challenge I observe is whenever the open source library, they release a security advisory, they will just release to public. And if a vendor uses the library, they will get a notification at the same time as the public. For vendor, in order to apply the patch, they will need to do a regression test. They will need to push the patch to customer. So essentially, this leaves a a gap for the vendor to scramble to make the fix and make their customer vulnerable. So I'm wondering whether you have any comments in this process.
So it's a really tricky problem. There's no really very good notification infrastructure for this kind of data, right? Ryan mentioned earlier, like you got to go check NVD or CVE or SecUNIA or somewhere to find that the particular library you're using had some security bug. In fact, a lot of times the security bug never even makes it to those repositories. You got to go check in the mailing list or the subversion check-ins where they said like fixed an input validation bug. Well, you really dig under that, and it was a terrible security vulnerability that they just patched in that version, and the data never went out about the vulnerability. So if you spin it forwards, really we end up in a place where it ought to work like operating system updates have gotten to now, right? Like we really want a library update service that just it patches it automatically. And if you think back 10 years or 15 years, operating system updates were terrible. There was all that regression testing and all that kind of painful work that had to go on for every single time a patch came out. And now they happen pretty much automatically. In fact, my Windows machine seems to just want to reboot randomly at any time. I've had it happen during a presentation. But we've come a long way in that dimension, but we haven't done the same thing at the application layer. And it's going to take time. It's going to be awful.
All right. I want to focus back in as we start to wrap things up. What can we expect from A9? Now that we're on A9, on the OWASP site itself, where are we going to take that project?
Well, I think for me personally, I'm extremely happy to see that we're actually getting back to some of the sort of basic blocking and tackling. Because it's one of those things which is it seems so obvious. Hey, should you be using things that have known vulnerabilities with exploits that you can Google and Rapid7, Metasploit with an actual exploit? Should you be using that in your software? Right. Well, the obvious answer is no. The fact that it's taken us so long to recognize that as an industry, oh my God, yes, this is basic blocking and tackling. We should absolutely be doing this. To me, that's step one. Because we're still in a place where a lot of organizations are still just arriving at that same conclusion. I mean, I don't know how many security reviews I've done in which the last thing I thought of was, oh, am I using any components that have known vulnerabilities?
Did you mean by the last thing that you thought of that you never thought of it? Like,
yeah, well,
it wasn't like the last thing you did in the review. It was like you never actually did it, right? Because I'm totally with you.
Yeah. Oh yeah. And all of a sudden, it's like, oh, wait a minute. There's this whole other universe happening inside my application that I didn't really pay attention to.
Yeah. So, Mark, you asked, where does this go?
Yeah.
And I think that's a really interesting question. So, we've talked a lot about A9 and known vulnerabilities within the libraries, but I really want you all to think about the unknown vulnerabilities that are in those libraries as well, right? For every known vulnerability in a library, that means one that some random security researcher discovered and decided to publish, there's probably dozens or hundreds more unknown vulnerabilities in those libraries because they're not really well scrutinized. And so I think as you think about your component usage going forward, what you ought to focus on is not just make sure that you have no known vulnerabilities, but also, are you using the libraries in a way that you have confidence that you're not introducing unknown vulnerabilities? So let me give you an example. So a library could have a hidden flaw in it, like it might have a SQL injection flaw buried under the hood somewhere, but it might also just have calls that are hazardous. Like maybe it's a method that just wraps runtime.exec. It's in Ryan Berg library, and it's just called Berg.exec. And so your static analysis tool doesn't see it. You analyze your code. It's just a call to Berg.exec, and I don't know what that does, so I just skip it, right? But really, it's a hazardous call. If you pass untrusted data into that call, then you've got a serious problem. So we need to do a better job of what I call whole app analysis, right? We need to look at not just the custom code and skip the analysis of the libraries. We really need to look at how the flaws happen across the entire application, and it's hard. It's, if you've got an application that's 3 million lines of custom code and 196 million lines of libraries, how are you going to build a model of all that and test it? So, there are new approaches. I'm encouraged about the use of IAST for this kind of problem, where we can do this whole app analysis and see where the data flows run into libraries and the data runs back out of the libraries and so on. So, I think really there's a whole level of analysis that needs to happen there, and that's really where I see this going down the road.
Ryan, in general, what is Sonatype doing with A9? How are you guys handling that as Sonatype?
Well, I mean, that's a huge focus of what we do. We look at how do we think of the broader ecosystem from a supply chain standpoint and bringing supply chain mechanics into the way in which we build software. So we're looking at how do we look, to me, I want to understand what happens when developers touch keys to keyboards, where they're consuming things, are they the right things, are they making good choices, are those choices that we're making in development, are those same choices happening in CI? And when things move from CI into production, are those assumptions that we made of what happened actually way earlier in the chain? Can we actually attest that those things actually occurred? Can I build, an attestation, right, that this is what should happen and this is what the result should be? Can I actually understand and reason about my software throughout that entire supply chain? So that's one of the, a big area of focus for me and for Sonatype is to bring more visibility into how the modern software ecosystem has changed, and how can we reason and make, I would love to be able to get to the point where we can actually say, stamp these things. You can understand that, yes, I want to sign off and I know what's in here, I know what's good, and I give it the seal of approval so that the next generation behind me can take that forward. We don't lose that information.
Thanks. Jeff, 30 seconds. What you guys working on?
Well, I think, what I think is important, and certainly that, getting that metadata right and making it available is great. I want to be able to allow folks to make policy choices about which choices, which libraries they're going to bring in, what attributes of those libraries. Take that policy and automate it. Make it continuous across the whole development process so that you should be able to change a rule somewhere to say, if the simple rule is A9, I don't want any vulnerable components, that should be pushed out immediately to everything. But you should be able to add a policy that says, I only want software with developers who've had AppSec training or whatever, and enforce that rule continuously across the life cycle.
Great. Thank you, guys. I hope you got something out of that. It's an interesting thing that's happened because it's so ubiquitous but so invisible. Ryan and Jeff, you have a session at 2 o'clock again, right? You guys are doing something at 2 o'clock?
Yeah, that's right. We're talking about go fast and be secure.
Yeah, so there's going to be more singing and dancing.
More singing and dancing. I actually have a session myself called Wait, Wait, Don't Pwn Me, which is built on the NPR show Wait, Wait, Don't Tell Me. That's going to be at 1 o'clock. I hope to see you there. And as you're leaving here on the front table, we do have a white paper about using components with known vulnerabilities. So if you pick one of that up, we'd appreciate it. Thank you so much for your time. Very much.